So, the first one, it asks us to just simplify the equation. So we're working with our power rules. So what do? You divide 35 by 3? What should we do first before we do that one? Not separate them, but we have 2 on top, right? We can combine those, right? Because they have like bases. So if they have like bases, we can always combine their exponents, right? So 35 and negative 27, how do we combine them? Not multiply. Adding. Yep. So what is e to the 35th times e to the negative 22nd? What do you get? 9. And then we don't similar. Subtract, yes. Because remember that to get a fraction, we have negative exponents. So if we want to bring this up here, I don't know if you guys have seen this before, but this actually is the same thing. Written like that. Have you guys seen that before? No? Okay. But we subtract them. This is just the same idea. We just subtract them, okay? It's just written differently. So what do we end up with? E to the 6th, yep. And that's as simplified as it can go, okay? So, this is really applicable to our lesson, you'll see, because E is actually a number, sort of. It's like pi. You guys know pi? 3.141569 or something. I don't know what pi is. You guys know pi though, right? Okay. It's like the idea of pi. E also stands for a number. Okay? But when we're simplifying it like this, we can first treat it like a variable to simplify it as much as possible. Okay? And we'll see that more in our lesson today. But I just wanted you guys to work with it without knowing. So, all right, number 2. Suppose Laura invests $4,800 in an account earning 4.5% interest. How much money does she have after 20 years? Show your work to justify your answer around the nearest cent. So what is our equation again? A equals P. Oh wait, real quick. Our the formula that we always plug things into first. Oh, did I put it up there? Oh, just kidding. Ignore that. Never mind. I didn't realize I put it up there. So, okay, you guys have it. Cool. What is our principal? Yep, $4,800. What is R? Yep, 0.045. It comes from our 4.5 interest, but we have to move the decimal 2 places. And then what is our N? Well, our N actually depends on which one we're doing. Just kidding. What's our T? 20 years. T is 20. Okay? So what is our N for compounded annually? One. Yeah. Compounded annually, it's 1. What's our N for compounded monthly? Monthly?
Oh.
Sorry.
12.
And then what's it for weekly?
52.
52. Yep. All right. So we just take these and we plug them in. So we got, for our first one, we have A, 4,800 equals 48. Whoa. 4,800 times 1 plus 0.045 over 1 times, or to the exponent of 20 times 1, which is just 20. Okay? So what do you get for A for the first one? What do you get for the first one? We'll plug in our calculator. If you don't have a calculator yet, you should go grab one. It is a long number. What is it? 11,576 and 23 cents. Got to round, remember? Yep, round to nearest cent. So it's 227, which means we round that 2 to a 3. Yeah.
Oh, I just need help on how to type it in.
Oh, know how to type it in? Yeah, okay. If I stop this, it'll just...
Your score will still go.
Okay. I'm gonna stop this real quick, and then I'll show you guys up here. Okay, so... I gotta go back up to mine so I can see what the equation was. There we go. Alright, so we type in 48...
You can make the calculator be a normal size.
Oh, it's okay. They can see it right here easier. This is easier.
It's just a really slight.
Oh, yeah, no, it's okay though. Like... Oh, okay.
So we can see the button.
4,800 times, and then it's 1 plus, and then it's your ND, N over D. Okay? That is second column, third row. Okay? N over D, and then you type in your 0.045, and then you click your next arrow button. That next arrow button will bring you down to the denominator. Type in 1, and then you click your next arrow button again. And then that'll get you out of the fraction. And then we want to, oh no, please close the parentheses. And then caret's how we get our exponent into the 20th power. Does that make sense though? Okay, cool. Yep. All right, and then click enter. And that's the number you should get, 157.6. Oh. Cool. Sense? All right. Okay. Compounded monthly. Just fill in our equation again. A equals 4,800. 1 plus 0.045 over 12 to the what power? 12 times 20, which is 240 if you want to know it beforehand, but type it in your calculator. And what do you get for A? 11,786 and 24 cents. Good. All right, and then compounded weekly. A equals 4,800 times 1 plus 0.045 over. What's our N for this one? 52. That is a really bad 5. 52. To the 52 times 20. Okay? So type it in again. And what do you get for A?
Oh, I didn't catch that.
That's falling. Nope. Anyone else type it in? What'd you get? 11,000? Give me 1 second. Oh, make sure you take this as an exponent. So it's caret, yep. Your decimals, it's 0.045. Yeah. All right, did anyone get 11,801? Yep, 11,801 and 50 cents? Yeah? Okay. 11,801 and 50 cents. Cool. Make sense? Awesome. Okay, so if you get your workbooks out, flip to page 373. We're going to be in 7-3 today. Kind of working through some things. So we're going to kind of do the first half of 7-3 today, and then we'll do the second half on Friday, because you guys have e-learning day tomorrow. So lucky you. You don't have to come to school. 373. All right, everything good on this slide? Yeah, 373. Okay, so we're still talking about exponential functions, but these are going to be with base e. Has anyone heard of base e before? No? If you look on your calculator, you can actually see base e, and it is right above your ln button, which is underneath your second button. So look at your calculator, look at the green button in the top left corner. 2 underneath that, you will see your ln button. If you were to click second and then click your ln button, you would get your e, your base e. Okay? Make sense? So it's already on our calculator, which is beautiful, because we're going to need that eventually. But anyway, the constant e has certain mathematical properties that make it a convenient base for exponential functions. Okay? E is the irrational number that's 1 plus 1 over n to the n power. Does that look familiar? Kind of looks like our compound interest formula, right? Just a little bit. Approaches as n approaches infinity. This value is approximately equal to 2.7182818. Keeps going on, okay? It's a lot like pi, like I said. A lot like pi, okay? Pi and e kind of have the same idea. They're represented by, e is represented by a letter. Pi is represented by a symbol. But they both represent a number, okay? Make sense? So, graphs of exponential functions with base e display the same general characteristics as other exponential functions. So as you can see in our graph on the right, it looks very similar to all of the growth functions, the exponential growth functions that we had been looking at last week, okay? So as f of x approaches an asymptote of y equals 0, x approaches negative infinity. That's what we were talking about with our end behavior with our growth, exponential growth functions. And then as f of x approaches infinity, meaning as f of x goes this way, x approaches infinity, which means x goes this way. So this is f of x. X will continue to go that way. Does that make sense? And just like with our parent functions and our exponential growth functions, our y-intercept, if you notice with our parent functions, which was anything of the formula or the that looked like this. It was just a number to the x power, right? They all had a y-intercept of 0, 1. Because any number raised to 0 power is what? 1. Yes. That's why we are always, with our parent functions, always had a y-intercept of 1, okay? We always had a asymptote of y equals 0. Okay, so very similar to our parent functions with exponential growth functions. we have e, very similar, okay? E just represents a funky number. All right, everyone grasping the concept of e? Just think of it as a number. But the beauty of it is when we have it in things like this, we first want to treat it as like a variable. It does things just like a variable does, just like a number were to do, okay? If I were to have 2 to the 7th times 2 to the negative 2nd, I could combine these, right? Because they have the same basis, right? So just like that, we can do that with e, okay? So here I have e to the 7th and e to the negative 2nd being multiplied by each other. What is my new exponent? E to the 5th. Because 7 plus negative 2 is 5. Okay? So remember that when we multiply things, if we're multiplying x times x, we add, I'm going to put a, we add their exponents. And then if we have something raised, an exponent raised to another exponent, or sorry, yeah, I said that right, okay. Then we multiply their exponents, okay? Does that make sense? Just remember that, it's really important to remember, okay? So B, what am I gonna do? What did you say? To the 4th, yeah, we're gonna take it to the 4th power. So if you want, if this makes more sense to you, you can take each individual term, so negative 3, and then e, and raise them to the 4th power on their own. And just remember that they're multiplied by each other. Yeah, exactly. Because sometimes when we see something in a parentheses like that, we just want to multiply our exponent towards our other exponent. And we forget to bring it to the negative 3. But we have to remember that every piece inside that those parentheses is getting raised to the 4th power. Okay? So what is negative 3 to the 4th power? It's negative 3 times negative 3 times negative, thank you, 81. Yep. So we get 81 here. And then here, when we raise an exponent to another exponent, what do? Not add. Not on the 81, because when we take, this is 4 times, so it's negative 3 times negative 3 times negative 3 times negative 3. These are going to be what? Negative 3 times negative 3 is what? Negative times negative is going to get you positive 9. Same thing over here. And so now we have 2 positives multiplied by each other. 2 positives multiplied by each other are always going to get us positive. Yes. You have to put the negative 3 in parentheses in like the negative and the 3 in the parentheses in your calculator, and then raise to the 4th. And that will get you positive 81, which is the correct answer. If you forget to put the negative in the parentheses in your calculator and you put negative and then 3 to the 4th, you're going to get negative 81. And that's not correct, okay? So don't forget to put the negative in the parentheses, okay? So, okay. So then e to the 2x raised to the 4th power, what do we do when we raise an exponent to an exponent? Multiply them. So 2x times 4 is 8x, yep. 8x. And then we just put these back right next to each other. All right, and that's our final answer. Does that make sense? Yeah? For the most part? Good. All right. We have a division bar here this time. So when we're dividing, what do we do with their exponents? Subtract. So when we multiplying the bases, we add their exponents, and when we're dividing the bases, so if I were to do x to the a over x to the b, you end up with x to the a minus b. Okay? Make sense? So same thing here. Is 42 divisible by 14? I actually don't know. My brain's not thinking. What? That's right. I did know that, but I just wasn't sure if we got an even number. Do we get an even number? What is 42 divided by 14? 3. Yep. And then e to the 7th divided by e to the 5th, what do you get? E to the 2nd. All right? Make sense? Everyone good with this? I mean, I feel like most of you have probably been over this before when you were talking about variables of the same basis, combining variables and their exponents. So this is something you guys have probably worked on before. So next page, we're just gonna do some more work of this, but I'm gonna give you guys like 3 minutes to work on this on your own. Okay? So it's your check, which is at the top of page 374. So do all 3 of these. If you have questions, let me know. And then we'll continue on. I'm just passing back some stuff, by the way. Yeah, there's. Okay, recycle all of them. You said? Yeah, you can recycle all this. Cool. Alrighty. Everyone good? Any more time? Okay. E to the 4th times e to the 3rd times e. What do you do to their exponents? Add them. So 4 plus 3 plus 1. 8. So you get e to the 8th. E to the 8th. All right. 6e squared to the 4th power. What's 6 to the 4th? What'd you get? Sorry. 6 to the 4th. Yep. 1296. And then what's e squared to the 4th? Yeah. E to the 8th. All right. And then 6e divided by 12. 5. And then e to the 6th divided by e squared. E to the 4th. Cool? Good? No, yeah? Okay, cool. All right, we have about 10 minutes. Perfect. So we're just gonna go over, if you flip to, oh no, it should be on the same page you should be on, 374. Page 374, we're gonna go over graphing with E. So again, very similar to all of the exponential functions we've already done. Just this time you're gonna have a base E, and just represents a different number, okay? So E is gonna be very applicable in the next chapter as well. So that's why you start to learn it with exponentials, and then you continue using it, okay? So part A is graphing the function. So the function g of x is equals negative 2e to the x minus 3 plus 2 represents the transformation of the graph f of x equals e to the x. And they did a beautiful thing for us here, and they actually graphed the parent function and then also graphed our transformation function, which is really nice to be able to see. It's so we can see where our graph went when we added extra numbers in or multiplied it by something else or changed our exponent, okay? So this is going to be very similar to our standard form of our exponential functions. Do you guys remember our standard form? F of x equals a times b to the what? X minus h plus k. Remember that? Okay, so in this instance, what is our A? Bless you. Negative 2. Yep, negative 2, which means the graph is reflected across the x in the what? There we go. That's a blank. You should answer. Across the what? What's the graph reflected across? X-axis. All right, and then it's stretched. So this is kind of, okay. Which way is it stretched? We know 2 is greater than 1, right? The absolute value of our A is 2. It's greater than 1, so that means we know it's stretched, and it's always stretched which way? Is it stretched vertically or horizontally? Vertically. All right. And they give us our h and our k, which is h is 3. Remember, because h is the opposite value. It's the opposite sign of the one what we see in the equation. So the graph is translated how many where? How many units? 3 to the right. Yep, 3 units. Right. And so k is 2, so the graph is translated up 2. So 2 units up. Makes sense? Very familiar, right? You guys have worked with this a lot now. So now we just want to determine our domain and our range. What is our domain? What are we looking at with domains? Our x's. So as it goes towards positive infinity for x, does it keep going? Yes. If we go towards negative infinity for x, does it keep going? So what does that mean? All real numbers for our domain. So put the big R. Or you can put negative infinity to infinity. And then our range, we're looking at the orange graph, because the orange line is our transformed line. Oh, Marian. The blue one is our parent function, remember? So looking at the orange one and our y's, our y direction, because we're looking at range, where does it keep going as it goes towards negative infinity? Does it keep going is my question, actually. Yes, it keeps going as it keeps going towards negative infinity. It continues on forever. Okay? At y goes towards positive infinity, what does it keep getting closer to? What? Not positive infinity. Look at, as y keeps going this way, what does this orange line keep doing? It's straightening out towards what number? Do you remember what the A word is called? Asymptote. It keeps straightening out towards, getting closer and closer towards our asymptote, which is 2. Yep. So the blue line I'm drawing here, or the blue dash line, that's our asymptote. It's along y equals 2. Okay? But as the orange line keeps going towards positive infinity, it's going to just keep getting, as x goes towards negative infinity, it's going to keep getting closer and closer to that dashed blue line. Okay? So the range is actually going to be negative infinity to 2. Does that make sense? Or you could say all real numbers less than 2, which means that I think some of you guys write it as y less than or equal to, not less than or equal to 2, sorry. Less than 2. Sometimes you write it like that. You see it written as that. Does that make sense? All right. Got a few more minutes. Is everyone good on this slide? Okay. Same page, 375. Looking at, oh no, not same page, sorry. The top of 375. We're just looking at the check. Since we only have a few minutes, we're just gonna walk through it together real quick. We're gonna graph the function. Actually, I think we'll save this for morning of Friday. Does that sound okay? Just because the graphing part is going to take a little longer, especially because we're dealing with E for the first time. So we're going to wait to finish this Friday. Does everyone kind of grasping the concept of E? A little bit? Okay. Any questions so far? No? Okay. Perfect. All right. So we're going to do a mini skills check on Friday. It'll be at the very end. It'll be like the last 5 to 10 minutes. If we don't get time, we'll just do it Monday morning. We might not get time, but that's okay if we don't. Your 7-3 homework is listed up here. It is on McGraw-Hill. So you can go ahead and start that. Again, just like last week, there were things that you couldn't start for 7-2 homework when we started 7-2. That was because we hadn't learned it all. Same thing here. There's a couple things that we're going to learn on Friday and go through on Friday with 7-2 or 7-3. So you might not be able to do all this homework right now. That's okay. Module 7 test is going to be next Thursday, so it's a week from tomorrow. So all next week, besides the skills check on Monday, potentially, all next week from Monday through Wednesday is going to be review. Okay? Sound good? Cool. Yeah. Good job today.